Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. We are presently studying marine boilers. Today we have 25th lecture and the topic is boiler combustion control. In this lecture we will first discuss the need for boiler combustion control and various methods used for auxiliary boiler on motor ships. We will then learn combustion control for large boilers used on steamships and conventional oil tankers. Lastly, we will discuss various methods for monitoring good combustion in boiler furnace. Good combustion control is necessary to improve the boiler efficiency and to avoid emission of black smoke in compliance with Annex 6 of MARPOL. All fired boilers on motor ships are usually of small capacity and used for short period during port stay only. These boilers earlier used on and off control which caused frequent emission of black smoke during the starting every time. To keep the boiler firing continuously, two burners may be used in which low capacity burner fires continuously, high capacity burner can start at lower setting and stop at control point, thereby maintaining steam pressure between two specified limits. An electric motor driven by variable frequency drive can operate both forced draft fan and oil pump so that steady pressure can be maintained by varying the quantity of air and fuel. The methods discussed above are not suitable for large boilers on steamships or on conventional oil tankers because load variation can be very large and quick response is required for maintaining adequate combustion during sudden load variation. For large boilers, the combustion control is discussed below. The sketches graphically represent high and low signal selectors which are used in combustion control system. Optimum performance of combustion control is essential in response to load changes for maintaining stability. If the steam demand or load on boiler increases, which is revealed by drop in steam pressure, then air and fuel will have to be proportionally increased to maintain steady boiler pressure. If fuel is increased first, then it will lead to black smoke and inadequate combustion. When load changes, response of the fuel loop is comparatively faster than response of the combustion air loop, which requires that combustion air flow should always be in excess than the fuel to prevent inadequate combustion and black smoke. This is achieved by high and low signal selectors in the following way. Here we can see that two signals are coming, the high and the low signal, and we can see that the low signal is blocked and high signal is going to the output. The combustion process works in such a way that during the increasing load, it increases the air first and then increases the fuel by using high signal selector. It first blocks low signal and high signal goes to the output to increase the air supply. Here we can see that again both the signals are coming, but the high signal is blocked by closure of this spool and the low signal is able to go to the output. Similarly, during decreasing load, high signal is blocked and low signal passes to the output to first reduce the fuel supply. This sketch describes the flow diagram for the automatic combustion control system in a large boiler. Combustion control system consists of a master controller which maintains steady steam pressure irrespective of changes in the boiler load. Two control elements, that is steam flow and steam pressure, are used to measure the load. So we have the master controller which senses the steam pressure and steam flow. It also consists of two slave controllers which are used to independently control fuel and combustion air supplies to the furnace. So we have fuel flow controller and air flow controller. Steam pressure is sensed by the steam pressure sensor, which is compared with set point and supplied as input to master controller. The summing relay output is steam flow signal plus steam pressure signal. So we can see the boiler pressure is sensed and compared here and sent to the master controller. This also receives another signal from steam flow, and both these signals are compared in the summing relay here. In addition to this steam pressure, steam flow is additionally measured and fed to the steam flow transmitter. So steam flow is measured and sent here to transmitter, but this signal is a square signal. It is made linear by passing through square root converter, which we can see here, passes through square root converter and finally comes to the summing relay. As steam flow is a square signal, it is passed through square root converter and fed to summing relay as linear signal. Summing relay also receives a signal due to deviation in steam pressure and averages the two signals. The summing relay output is steam pressure signal plus steam flow signal and represents the fuel signal depending on whether the value is high or low. Then we have low and high signal selectors, which are used to increase the air first in case of increasing load and reduces the fuel first in case of reducing load. Master controller sends its output signal to the slave controller through high and low signal selectors. Also, the fuel flow which is passing to the furnace is measured, and it is again a square signal passed to the square root converter and fed to high signal selector and the fuel oil flow controller. Fuel flow transmitter receives fuel flow signal and transmits to fuel flow controller and high signal selector. Similarly, the air flow is also measured, which is the difference between the pressure in the furnace and the pressure in the air register. This again is a square signal, so it is passed through the square root converter and sent to the controller and low signal selector. Similarly, airflow transmitter and square root converter receive airflow signal measured across boiler furnace and air register. Square root signal is converted into linear signal by square root converter. Here we have air fuel ratio adjustment. This is used to adjust the air and fuel ratio in case the combustion is not as desired. Airflow signal is sent to the airflow controller and low signal selector through air and fuel ratio adjustment, which is used to control oxygen content in the exhaust gases when boiler is used for generation of inert gas on conventional oil tanker. If the oxygen content in the inert gas increases beyond the specified limits. If the load is reducing, then this low signal selector will pass the fuel signal to the actuator through auto manual station to reduce the fuel first. In case of reducing load, fuel flow controller takes lead to send lower signal to fuel flow actuator through auto manual station. And similarly, in case of increasing load, the airflow signal is increased first. In case of increasing load, airflow controller takes lead to send higher signal to FD fan actuator through auto manual station. Auto manual station is used to control individual actuators manually when automatic control malfunctions. When combustion control system is modulating at minimum load, steam pressure can be maintained by dumping excess steam. Now we will discuss methods of monitoring the combustion in boiler furnace. First of all, let us understand what is the need for monitoring the boiler combustion. Efficient combustion in the furnace is essential for keeping the heat transfer surfaces clean, thereby increasing the efficiency of boiler. About 10 to 30% excess air is adequate for good combustion. Excess air below 10% causes incomplete combustion, resulting in black smoke due to emission of carbon monoxide with reduced efficiency. Similarly, excess air more than 30% results in increased deposits due to formation of carbon trioxide and lowers efficiency as extra air takes away heat from the furnace. So we can monitor the combustion simply by seeing the color of the exhaust. It is the simplest method for auxiliary boilers on motor ships which are operating at fixed capacity. Air supply damper can be adjusted once to provide a light brown haze as seen from the boiler funnel outside the engine room. So this method can be used on relatively large boiler, and this method is sometimes used on large boiler where combustion rate varies. It works on the same principle of seeing the color of the exhaust, but the operating personnel need not go outside. A periscope is used to see the light source positioned between periscope and the boiler uptake. Clear light indicates good combustion, whereas reduction in the light intensity indicates of poor combustion. Ringelmann scale is used on some of the boilers. So, some of the large capacity boilers are equipped with a Ringelmann scale, which measures the density or opacity of smoke. The scale is divided in 6 sectors from 0 to 5. For good combustion, the scale should read between 0 and 1. Scale 2 may be just acceptable, but 3, 4 and 5 should be always avoided. Main boilers on steamships and auxiliary boilers on conventional tankers are equipped with CO2 and oxygen analyzers respectively, which serve as useful tool for monitoring the combustion, and following slide describes relationship between excess air and CO2 or oxygen. This graph is drawn for percentage of carbon dioxide and oxygen on the ordinate with excess air on the abscissa. So, we can see CO2 and O2 on the ordinate and excess air on the abscissa. We can see this is the carbon dioxide curve, and also we can see that if the carbon dioxide in product of combustion is between 12 to 14%, the combustion is said to be efficient. Good combustion is achieved when carbon dioxide in product of combustion is between 12 to 14%. This corresponds to excess air between 10 to 27%. We can see corresponding to 14%, the excess air is 10%, and corresponding to 12% carbon dioxide, excess air is 27%. Automatic combustion control is adjusted to achieve it on its own. When the percentage of carbon dioxide lies outside this range, readjustment of combustion control system becomes necessary. On conventional oil tankers, boiler is mainly used for production of inert gas to prevent fire or explosion in the cargo tanks. Oxygen analyzer is an essential equipment of the inert gas plant. This also serves as a tool for monitoring the combustion in the boiler furnace. We can see here that this is the oxygen curve, and we can see that the oxygen content is maintained between 3 and 5% while generating the inert gas. Inert gas produced from the boiler flue gas should have oxygen content between 3 to 5%. From the curve, it can be established that corresponding to 3% oxygen content, excess air is about 15%, which we can see here. Similarly, corresponding to 5% oxygen content, excess air is about 27%. So, we can see 5% oxygen corresponds to 27% excess air. This completes the study for the need of combustion control in boiler, various methods employed to control boiler combustion, and monitoring the quality of combustion in boiler furnace. This book is written by me and covers all the topics as per Indian Maritime University syllabus. It is also recommended by Indian Maritime University as a reference book. It clarifies the concepts with simple illustrations. This book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. This book can help the students in preparing for the exam and also to work on ship's boiler safely. Hope you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share it with your friends. You may subscribe to the channel for getting notification about the new tutorials. I will be back with a new lecture shortly. Thanks for watching till the end.